Hello everyone, welcome to today's class. Today we have a very nice algebraic challenge before us here, and in this algebra, if you watch carefully, there are no numerals. All we have here is variable, and the variable is just x or true. Another observation from this question is the base on the left hand side is the exponent on the right hand side, and the exponent on the left hand side is the base on the right hand side. So how do we solve for the value of x in this challenge? It is as simple as ABC. So let's take our solution. First thing first, according to a man called Steve Arrow Carvel. I believe some of you know this man, a very notable man. So let's go straight to our question. Oh, yeah, the first thing we're going to do here is just to rewrite the radical we have here. We have a square root radical. So rewriting in this will give us here x to the power of x times x all to the power of 1 all over 2. This is equal to, then bracket open, x times x all to the power of 1 all over 2 all raised to power what? X here. So what we do next here, it is very easy. We have to use this S to open these guys that are in bondage, because the bracket here is like bondage. So let's free them from this bondage. So we apply the law of indices, which says that if you have your m to the power of ab, this is equal to your m to the power of a bracket, your b here, which is equal to your m to the power of b bracket, your a. Okay, so we can twist these two up and down, in and out. So if we apply this rule here, then we can open this using this exponent here. So this in turn will give us our x to the power of x times our x to the power of 1 all over 2. Then this is equal to x to the power of x times our x to the power of x all over 2. As easy as ABC, right? Okay, so what we do next here, all we just have to do is to apply the law of indices again, which says that since the bases are the same, then we can add the exponent, the same thing here. Okay, this is to the power of 1. So let's go ahead and do that. So we're going to have this to be x or to the power of x, then plus your 1 here plus 1 all over 2, rather, which is equal to, we have our x to the power of your x here plus x all over 2. Good, 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 good. So can I add this, and at the same time add this together? So we have x here. Okay, let me write my x very well. X equal to our to the power of x. Then we have a 3 all over 2, which is equal to x to the power of the same 3x all over 2. Check out the bases here. The bases are the same. So since the bases are the same, so we can equate the exponent according to the law of indices. So we're going to end up having your x here to the power of 3 all over 2 equal to 3x all over 2. So what we do next from here, all we just have to do is to make x to be on one side and the constant on another side. So let's divide by x here. We divide this side by x here. This is to the power of 1. So this x goes with this x. Then we move this one up here. So we're going to have this to be x to the power of 3 all over 2 minus 1 equal to 3 all over 2. Easy. So if we carry out the subtraction here or the simplification here, we're going to end up having our 1 all over 2. So we have x to the power of 1 all over 2 equal to 3 all over 2. What we do here, let's square both sides of the equation because we're looking for x. So we key this radical off. So we have the x is equal to our 9 all over 4, right? So therefore, x is equal to 9 all over 4. Okay, sorry. So we have the x. So 9 all over 4 is the value of x that will satisfy this original equation. What we have to do is simple check for the benefit of doubt. All right, so check the equation again is x to the power of x times this square root of x like this equal to your bracket open x times the square root of x all to the power of x. Then wherever we see s, let's put in words 9 all over 4. So this will now give us 9 all over 4, which is the first one, all raised to 9 all over 4, then times the square root of 9 all over 4. This is equal to our 9 all over 4, right, times the square root of 9 all over 4, close bracket, all raised to 9 all over 4. Wow! So the square root of 9 is 3 and that of 4 is 2. So we can rewrite everything we have inside this radical as our 9 all over 4, right? All raised to 9 all over 4, then times your 3 all over 2 equal to, bracket open, 9 all over 4 times 3 all over 4. Sorry, all over 2 here, please. 2 all raised to what? 9 all over 4. So what do we do here? Look at this guy here. I want to move this inside here according to the law of indices we just looked at, right? So if we do that, we're going to end up having your 9 all over 4, okay, all raised to your 3 all over 2. Then let's put this in a square bracket, all raised to 9 all over 4. This is equal to 9 all over 4 times 3 all over 2, all raised to 9 all over 4. Easy. Okay, so what does this mean? This is root. Okay, so if we take the square root of everything we have here, this will give us here, this will end up giving us your 3 all over 2, right? All raised to power 3, all to the power of your 9 all over 4. This is equal to, the, let's still keep this side here, the times 3 all over 2, all raised to 9 all over 4. So what is 3 to the power of 3? That is 27. So we have here 27, right? All over your 4, sorry, 8, all over 8 here, then all raised to your 9 all over 4 equal to, we can multiply this out here. So we have here 9 times 3 will give us what? 27 all over 4 times 2 will give us what? 8. So all raised to what? 9 all over 4. Now let's check the left hand side and the right hand side of this expression together. We are having here 27 all over 8 all raised to 9 all over 4, and on the left hand side we are having 27 all over 8 all raised to 9 all over 4. So this confirms or shows that the answer 9 all over 4 are solved for, so this algebraic equation satisfies the original equation, which is this before us here. So however simple this approach or this math problem may appear to you, if you like it, then give it a thumbs up. If you learned something from it, just give it a thumbs up. But if you've not learned anything from it, still give it a thumbs up because it's not easy. Thank you for being there all the time. You are the reason for the existence of this channel. That's why we love you so much. Bye for now.